TeachMePCB. I'm the creator of TeachMePCB, Mark, and with the gracious support of our sponsors, such as Advanced Assembly and Royal Circuits, we're able to bring this to you for free, which is pretty amazing. And joining me tonight, we've got Brian Lindhall of Lindhall Engineering, as well as Elliot of Elliot Made. I don't know where that came from. I guess I had it open in the background. Sorry about that. Welcome, gentlemen. How are you?
Not bad.
Good. Oh, good.
All right. Good talk. Good talk. So what's the latest? What can we do for you guys tonight?
All right. Good talk. Good talk.
I've got it. I did an echo. Hold on.
Yep, somebody's echoing there. Was that you, Brian?
Yeah.
I'll let it slide, but just this once.
I was trying to get the chat broken out so I could
Oh, no worries.
keep an eye on it. But then it started playing when I got there. So
It happens. Well, gentlemen, how's the course treating you this week?
It's good. Yeah, go ahead.
no, go ahead. You started.
I was going to say, I feel like I'm good on this part, schematic-wise. Were we going to do any peer review of these things? Is
Of the schematic?
part of the plan? Yeah.
That's a great question.
For those of us that have deviated from the standard one, it seems like it might be helpful to post them up, and if anybody cares to look, have a look and see if anything is obviously wrong. Get some feedback.
Yeah, maybe in the forums. I don't know if I want to do a structured lesson just because I haven't announced it. But it might not be a bad idea to put it in the forums and see if we can't get some people to take a look at them.
Right. I wasn't suggesting doing it right now at this moment, but yes, the forums make sense.
Yeah. Only because I don't want to spend too much time on people who are going off the reservation, because so for example, right, things like your encoder issue, that's not likely to be picked up by anybody, right? So with people that are doing other things, we've got a bunch of engineers or people in the course who aren't necessarily electrical engineers. So the peer review that they'd be able to offer for people doing different things would be limited. We really need some professional engineers around.
Let me rephrase that then. Are we expecting everybody here to use a copy that they've grabbed from the library, or are we expecting them to use the schematic that they redrew to match the circuit that you've provided?
That's a great question. I would hope that they go to extraordinary lengths to ensure that the schematic that they redraw is the one that they use. That being said, I fully expect to get a schematic from someone, probably Jesse, but I don't know yet, and provide that for this next week's checkpoint for people to use if they're not confident that what they've done is correct.
Okay.
If that makes sense. Yeah.
I was thinking the likelihood of success if I started with every footprint I drew and then every symbol I drew and then the schematic I drew is pretty low.
It is very low. I would definitely recommend that you guys use our libraries.
Okay.
Use Jesse's libraries. They're proven. I thought we were just talking about the schematic capture aspect.
Well, I was just thinking in general, like we've been doing all these exercises, but if they're meant to add up to the final product without review, seems a little sketchy. So now I understand better.
Yeah. So a lot of the activities are meant to demonstrate how you would. Okay, so we're all on the same path, right? We're all going kind of in the same direction, or at least that's where I'm trying to steer the boat. At every critical step, I do want to provide you guys with known good files because I want people to be successful, especially their first time out. The likelihood, I agree, the likelihood of a new designer making all their own library files and all their own everything else is very, very low. The time that we will catch the problems that we're going to be able to catch, we are going to do a peer review after the layout phase. We can catch a lot of mistakes with our DFM software. We can catch a lot with our DFA. We can catch a lot through automated review. We will catch some with peer review. There are mechanisms to catch mistakes, but I don't have any mechanisms to catch them at this point.
Got it.
Because it really would take experienced engineers going at these things, and we just can't do that in volume. So, but yes, some error checking is in the works. Probably, so if you figure half a week, so 2 weeks from now, we should be in an error checking module.
Cool. Yeah, because I know at the beginning, we've got everybody comes up with a unique design, and some people are omitting one part or the other or 6 parts. So we can't all quite work from that same schematic if that's the case.
Well, see, that's one of the reasons I kind of want everybody going down the same path. If everybody's doing the same thing, the chances of a peer review being successful are so much higher than if people do their own thing. So that's why I'm happy to support you guys if you have other, let's say, closely related endeavors. But, people that are going way off the reservation, it's kind of hard. Now, the thing, too, that I want to remind people, this isn't the only schematic you're ever going to do in your life, right? Nobody ever says even that you have to buy these boards. But if you do, they're going to be how much from JLPCB? Like $25?
It's like $20, $25 to your door for 5 copies.
Yeah.
In a week.
It's pretty good. It is indeed pretty good. So I did something, and I've got to figure out how to make it useful. I recorded 8.5 hours of video of laying out a PCB. I lost you guys.
I don't know what to say about that. That's a lot of hours.
It's a lot of hours. It's a lot of watching. Yeah.
Well, a lot of it is me sitting here doing this. Staring and clicking. It needs to get edited down. I was hoping getting it edited down to 25, 30 minutes max. But plenty of it is just silence. It doesn't need to be digested, It needs to be cut screens. But anyhow, I wanted to show you what came of that, if you guys would care to see.
Sure.
Can I go full screen on this? There's no full screen. Yeah, F11's a grid. Okay. So, this is it. This is the board that I worked on starting Monday. Could not find any model. Okay, well, I haven't installed the models. That's fine. I don't care. I decided to make just a random shape to just kind of illustrate the things. This board will never be built, but I made it to kind of look like a ghost, right? Now, here's the cool thing about this particular board. That's the shape. It's nothing exciting. But if we look at the copper, how do I unroute? Clear all copper cores. And let's turn off vias. There we go. Every trace on this board has a return path of solid continuous copper. So for example, the USB, right? If you take a look at these USB lines, it does have to change sides, but there is absolutely nothing that breaks those lines. So if I turn the copper back on, objects, update copper pore. There is a solid copper plane underneath every millimeter of routed trace on this board. That's what makes it cool. It's complete overkill for our project, but whenever you do route a trace, whenever you have a digital signal, anything that's doing anything, there's going to be a certain amount of energy that's stored in the area around the trace. And if you can capture that energy, it won't radiate off into space. Kind of cool or not kind of cool?
Yeah, I was kind of proud on mine. I don't have it necessarily underneath every trace, but every trace has ground copper next to it. Well, I've spaced them enough so that the pores go in between everywhere. So I was pretty surprised to be able to actually do it.
Very cool. Now, something else that you want too, though, when you do have the, if you do have copper in here, unconnected copper can radiate. It's an antenna. So you want to tie all of the copper back down to each other. So for example, clear all copper pores. I'm going to have to go to a smaller scale here. Typically what you want is, these things tied in about every 1/10 wavelength of the highest frequency of your transition frequency. And we can talk about that tonight if you guys want to. Let's connect these. So those are all ground now. Object, update all copper. Whoop, no. Update all copper pores. Elliot, you're uncharacteristically white noisy tonight. Did something happen to your audio?
Is that me? I can't hear it. So.
Yeah, it's totally you.
All right. Weird. Let me see. Maybe I'm using the wrong microphone.
Oh, it could be. Yeah. So anyhow, you want these things tied at the edges and more frequently if you possibly can, so that you don't become an unintentional radiator of electromagnetic energy.
Yeah, I've got them all tied together. I don't know if I've got it off often enough, but
usually not, because it takes so flippin' long, and the stuff that we're routing doesn't necessarily need to be EMC compliant. We can route for connectivity and we're going to be just fine. How's
this better?
That is much better. Yeah. Wrong mic.
Okay. Yeah, the webcam that I have has its own microphone, which is terrible.
Yeah, it's really bad.
So you've got a copper pore on both sides of your board, and you're tying them together right now, right?
I have a copper pore on both sides. That is something that I like to do. I get into fights with other electrical engineers sometimes on that. I'm right. So the reason is that copper doesn't expand when heated. It conducts heat rather than absorbing the heat, and so you get these. And I'm sorry, I'm operating on like 3 hours sleep tonight. I did not have a good night last night. Anyways, variable or different coefficients of thermal expansion. So the laminates inside of these things, they absorb the heat and they use that energy and they start vibrating, and the molecules get further apart and they stretch and they turn. So if you've got a bunch of copper on one side and no copper on another, well, let's talk about what that looks like.
Pringle?
It looks like a Pringle, right? So here, I mean, if we're looking at this, other than the field of unnecessary vias, I've got a lot of traces that are going north and south on this layer. So this thing would be constrained in that direction, but it would be unconstrained from expanding in the other. So on the far side of the board, it's going to hold it. On the near side of the board, it's going to expand left and right. So this thing's going to turn into a potato chip when it goes through the reflow oven. Will it turn into a potato chip all by itself? This single board, no. Single board, it's going to be okay. It's when you put these things on a panel that it really becomes a problem, because then the expansion amplifies. It gets worse. So I always
that makes sense. I was expecting a more electrical reason.
What do you mean?
That having copper pour between a bunch of traces floating around on the top of the board provides something beneficial. But is that not the case? It's just whatever?
It's good thermally. It's going to help with that. Mostly what you're getting is the broadside couple returns. So like right now we're looking at the top of the board. The copper on the bottom functions as the return path for all of these traces.
Mm-hmm.
And the few traces that I have on the other side, the copper on the front of the board serves as the return path for that.
Okay.
So there are electrical reasons, but the primary reason that, and this is where I get into fights with there's a professor who I absolutely adore, and he's got a very different opinion on this. I've seen boards potato chip. I've had boards potato chip. I just don't think he's run into the problem yet. And since he's built plenty of boards, but he usually gets one-offs like the JLPCBs, right? So if you go to like JLPCB, PCBWay, whatever, and you order 10 boards, they're going to make 14 of them. And they're going to take the best 10 and they're going to ship them to you, and they're going to throw the other 4 in the trash. Which is cool, but I'd just as soon get all 14 working, you know?
Sure. Yeah, I'm looking at the board I have, and I didn't fill the top because it's totally full of traces all over the place, which is going to make a lot of islands, and then I'll need a lot of vias to connect them.
Which can be a pain in the butt. Like I said, for one-offs, for small boards, you get away with it. It's totally fine,
Okay.
Elliot.
Nope, your explanation makes sense, though.
Yeah, but when you start dealing with bigger boards, like maybe you're making a server or a PCB motherboard, you don't get away with it anymore. But if it's a little, 2-inch by 3-inch board, it's fine. Who cares? And then you don't have to do all of the, the via madness. So another thing, though, but you still, you're not going to capture all of these islands. So check your EDA software, and you should be able to remove unconnected things that don't exist, so that you don't end up with them becoming unintentional radiators. And then you don't have to go through and fill absolutely everything, but you get the benefits of mostly having them all done.
Yeah, KiCad, at least by default, does not fill everywhere. It fills what it can reach. it starts at the outside and fills in around everything. But it does if a space is too tight, it doesn't it doesn't fill it in by itself. Um, the ones where I've had a significant space that wasn't filled, I've been just putting a via in the middle.
Okay, and then
and then once the via is there, it connects to the ground on the other side, and it knows it'll flood up through it.
But yeah, absolutely. And then if you can use more than one, but then you still have to pay attention. So right now I just said remove all unconnected pores. But look at this one. It's just tied here. And is it tied up here? It's not. But I bet you I could get it to get tied up there if I just nudge this a little. So even though it is technically following the rule, it could still act like an antenna. So sometimes you do have to nudge things ever so slightly just to, get that last little bit that you need so that you don't have those things. So now I'm tied here. I'm tied there. It would be great if I could drop a via in if nothing's going on over there and tie it back down to the other side. But you do kind of have to look around and see if there's anything like that going on.
Yeah.
Because, that's really what antennas are, things that are grounded at one side and not the other. Clear all copper pores. So now I've generated an error of some sort. So there we go. That fixes it. So just keep an eye out for that kind of thing.
So on internal layers then, they're like laminated together, right? So the height depends on presence of copper or not. There's a slight difference. Are there ever any problems with, say, having no pore on an internal layer and traces scattered all over? Does that make a weaker bond than one that was a more continuous surface? Does that question make sense?
It does. If anything, I would say that it would make potentially a stronger bond from a mechanical standpoint. However, if you still have that unbalanced stack up, it doesn't matter where that copper isn't balanced, if it's exterior or interior. If you've got, just a bunch of traces on layer 3, but you've got, let's say it's a 4-layer board. You've got a bunch of traces on layer 3 that all go in one direction and a bunch of traces on layer, 2 that go perpendicular to it. It'll turn into a Pringles. You typically want your copper balanced. And again, if it's a small board, who cares? But if it's a bigger board, you typically want it balanced within, 80 to 90% of the other layers. So the easiest way to do that is just leave the copper on.
Sure.
Copper is going to be on the board to begin with. Just leave it there.
Cool.
So, yeah. So, Paul and Jeremy, how's it going tonight? Anything we can do for you, gentlemen, or if you'd like to join us on screen, feel free to. Seems like the three of us are kind of quiet. Oh, the conversations right now that are going through Elliot's head, I can feel them.
Yeah.
I got some more keys printed for this thing. It doesn't have a knob yet, but it's working. And some of the buttons do stuff. I don't know which ones though. Oh yeah, it's got different deal. So, anyways, it's working. It's great news.
Elliot, man, that is great news. Do you know about Adafruit's show and tell?
I don't, but I do have Google.
Okay, so
Wednesday afternoons, typically 4:30 or 4
so
o'clock.
before we come on here every Wednesday, they have a StreamYard. Hi, Matthew.
Good evening.
Good evening. And on that StreamYard, they do show and tells. And man, you got to go show that off. That's great.
Maybe I will. It's really hard to take a picture of, I found.
No, you show it the video, man. You just show up. You just,
Oh,
here's my
to
thing.
take a good
Woo!
picture. Things that emit light are difficult.
Yeah. And then also, if you would like to share that on Hackaday, I can put you in touch with Dan Maloney. He's a friend.
I gotta want to finish it up before I brag about it too much. But
okay. Well, just
I've got another. Yeah, need to make a knob. Need to machine a base for it. Need to wait until I have PCBs that are the final ones. I'm gonna wait. I've already revised it a few times.
Well, no, that's what I'm saying. So Hackaday, you're right. You want it a little more refined, but with Adafruit, you can show the same project in multiple stages. Go 1 week, here it is here. Next week, here's the improvements I made. They're all about that.
Yep.
Cool.
Yeah. Matthew, how are you?
Good. I enjoyed Monday night so much I came back. I am attempting my first SMD soldering. Got all my stuff, last of my stuff in today. So I'm sitting here with my 10x loop and my strips of components, trying to figure out what they are and measuring with my calipers. It's going to be interesting.
Don't sneeze.
Just as a hint, the resistors are black, the capacitors are brown.
Yep.
Aside from that, there's 4 sizes. They're kind of obvious. But yeah, I've got the same kit. I'm just,
and just trying to determine which ones are practice and which ones actually make up the final circuit, and so I don't use up the wrong ones.
On the sides are they don't hook up to anything. It's the stuff in the middle.
Right.
Good news is they're super easy to get off. You just kind of stick your soldering iron anywhere near them, and they fly off the board. It's no problem.
Well, and the thing I don't do the thing I did, which was have your hand twitch when you're just after you open up a strip of components before you dump them in the little box. Your hand goes like this, and all of a sudden there's resistors everywhere. And I've got carpet, so it's some of them are gone.
There are a couple things on Thingiverse. There's one that you can put a strip in, and then there's these deals. So I 3D printed this from somebody's brilliant invention, but
I saw that.
If you can see, like the you can get one component out at a time, but you kind of peel the top off in one direction, and then the strip comes out the other. Super helpful, because then you can like kind of get one and only one, and not make a huge mess, because they disappear immediately, even if you hear them bounce. So you can't find them.
Well, especially if you hear them bounce.
If you've got a printer, I'd definitely recommend. I'll see if I can find the one that's flat, so with the shorter strips, instead of having enough to coil up in there. But I've had a good experience so far in my one experience.
Yeah, I'd love to take a look at those too. Might be useful. And then I think too, Matthew, a few weeks ago, we did some videos on getting started with surface mount soldering. Have you had a chance to see those?
I believe I've seen them, yeah.
Okay.
Watched a few others too.
Yeah. Maybe it's useful, maybe it's not. I don't know.
Yeah. A couple years ago, I bought myself a decent Weller soldering station, and hopefully I might have to buy a smaller tip maybe, but
not always.
Yeah,
you'd be surprised. Sometimes too small can be that might be okay. That's about the size that I used on all the on all of the examples. So there's videos that I haven't released yet where I assembled my board with a tip that size, just to show it could be done, that you don't have to go out and buy necessarily anything. So, but I do if you don't have this tip yet, I
Flat.
do kind of like that one personally. So, yeah.
I'm kind of torn. I've used both that one and the fine point one, and I kind of go back and forth which one I want. I guess it depends on the part sometimes, because the smaller stuff I have real troubles even seeing and coordinating with the bigger tip. It's difficult.
Yeah, until you get that first pad tacked so the thing doesn't move, it's hard. Though it will definitely wander around on you.
And looking at these old 402s, those are some tiny little chips.
Oh, geez.
I can't see them anymore, Matthew.
My eyesight started going about 10 years ago. When I hit 40, I got the progressives, and it's just gotten worse every year since then. So I said, this little thing works pretty good.
That's cool. Yeah, they're not too expensive either.
No.
So, Elliot, what's left on yours? You're going to do another spin, you think?
Definitely. I think I'm going to try to build one. Okay, so my next version of this circle thing, the changes are I'm adding, and I posted in Discord earlier, I'm replacing some of the resistor footprints with ones that can be easily soldered to make a jumper.
Mhm.
Because I think I'm going to make a handful of these they seem like cool gifts for certain types of people. But since I've kind of figured that most of the passives aren't really required, give myself a shortcut if I want to skip all those important components, be able to assemble it without any of them on the board, just solder some pads closed. So I'm going to give that a whirl. I'm going to add some Neopixels to the reverse side so it can do what Jesse did and light up the bottom. And then also add another jumper to skip the top side Neopixels if I want to make a variation with it there. So trying to build in a little bit of configuration to it so I can have some options when I build it. I think that's the main thing I'm going to change.
Well, if you're giving them away, I mean, I'll throw my hat in the ring there. I'd love to have one for a marketing sample.
Yeah, no problem. The other thing too is I wanted to try it out. So I 3D printed keycaps here that are like pizza slices, which is kind of annoying to do, but I think it's going to be totally functional with regular ones. Just need to find some kind of knob that goes on there. I'm going to make mine, but I have another project in the lathe right now I don't want to take out because it's it's already indicated in, so
You'll never get it back.
Yep. But I think I'm probably going to do another design that actually follows like the reference circuit and uses the right components just to say I did and have another go at it because it's fun.
And you learn a lot, even if you lay out the same project, let's say you rip it all up and you lay it out 2 or 3 more times. You're going to learn something each time, and you're going to find a more elegant way to do things. It's not the way that you typically get to do things in the workplace, but this isn't work, right? We're doing this for fun.
Yep, I've drawn this one 3 times now. The third one's going to be the good one. But I also went up to 1206s because I figured why make things smaller than they need to be. I didn't have any trouble with the 0805s, but why not?
Yeah. Well, the nice thing about an 0805 is you can pretty easily route 2 traces in between the pads.
Okay, I was just sticking with 1. 2 seemed ambitious.
Yeah.
It's makes me uncomfortable thinking about it, but I know you can do it. But
Oh, I do things, Brian. I do things. I think I did it here just to say that I could. I forget where though. Oh, one of the funny things in the video that I'm going to have to edit, right? So I'm doing this layout, and I just kind of threw a layout in so I could show how to import boards and everything. I wasn't too worried about it, and I put everything down, and I get all the routing done. And so this is like, of the 8.5 hours, this is like hour 8 and 15 minutes. And I find this area of board that has nothing on it. And I'm like, this is really great. I could do some art or something. This never happens in professional designs. If you had this much space left over, you'd shrink your board so you could get more boards on a panel and, blah, 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 blah. And then, after I'm done with this little thing, I scroll out and I'm like, at some point during the day, I had highlighted that area of board and deleted all the components from it. Oh man. So I got to fix that off screen, but yeah, that was fun. But
so I have a question.
Sure.
I have a question about the Neopixels. I'm not familiar with them. When you send they're I2C or SPI programmed, right?
One
it's
wire.
Something else.
One wire. Okay. Now, are they individually addressable, or are they all getting set? Okay, so you could set each one in the chain to a different color.
Mm-hmm.
Yep. Okay. Cool.
Yeah. If you
Most
fill
of
out
the libraries, you just tell it. Yeah. Well, the Adafruit library, you give it an array of pixels.
Okay.
Or you create an array of pixels. You tell it what pin numbers they are, or what pin number and how many there are, and it gives you an array that you can set. And then it handles all the stuff, but it's basically just a shift register inside.
Okay.
That you pass stuff through until it reaches the end. It's actually,
and each one
cool.
Just passes it down to the next one in the chain.
Yeah.
Okay.
Yeah, they're super cool.
Can't wait.
And you can go. I think you can have pretty long chains. There is a limit to how many they can handle, but most likely your microcontroller will be the limiting factor.
Your power availability gets to be the limit.
Well, that's easy. You can just keep slapping power supplies on there.
Well, yeah. But I know they have strips. Shoot, how long are the long strips that they've got? In the hundreds of LEDs.
Yeah, they come in like 5 meters at a time. I've got some rolls of them up here, and you can power them all. You exceed what USB can do easily. But if you don't run them all at the same time, you can go pretty far.
Yeah, my other project that has a bunch of them in it, I only it's battery powered, so I only run them at like 30% brightness, or that I almost can't tell. They're so bright when you turn them all the way on. It's just not necessary to do.
So there's a YouTube video floating around out there I watched the other day. You guys familiar with those LED cubes that people build?
Mm-hmm.
So there was one a guy did with there's some through-hole Neopixels, like 5 millimeter LEDs or 3 millimeters, 5, yeah. But he did one that was 16 by 16 by 16, and it was more than like a kilowatt.
I saw that too.
It was pretty remarkable.
That's, yeah.
Do you have like solar or like hydroelectric powering that thing? That's crazy.
But yeah, that's a lot for just a bunch of LEDs.
Yeah. So Matthew, I see that you filled out I was going to say, have you filled out your parts request? I just checked. You have.
Yeah.
So I've got right now extras of some parts. Neopixels is one of them. So if you want more, we'll see how many people end up putting out parts request kits, but I could always send you some more too to play with.
That'd be cool. Thank you.
Yeah. You're going to have to remind me. I have the attention span of a gnat.
Yeah, if you want some to fiddle around with, there's a couple of good simulators online. Like you can simulate them in your browser, but also if you get an LED, so they sell them in strips, and you can also get like rectangular arrays of them. They're relatively cheap on Amazon. But if you want to get straight to the playing with it part and skip over the soldering it part, those are a good way to go.
Cool.
I've got a box of all of this stuff. Jeez. Yeah, they've got little ones. So this guy is what, 8x8. It's a handful of bucks, but it's nice because you can just plug it in and go for it.
Yeah.
Yeah, I've got lots.
One of the cool ways that they have them at from Adafruit is they put them on a little tiny circuit board, and each one just has solder pads on the back to chain them together with your own wires.
Okay.
That's what's inside. That's what's inside here on each one. So hand soldered 20 LEDs together. But they're it's pretty cool. It's just a little 9mm round board with the surface mount on it.
And Elliot too, man, if you're making, by the way, if going back, if you're making a marketing sample for me, man, I'd be more than happy to buy your board and parts.
Well, I don't worry about that, but I will send you one because you might as well have a few examples and you can do your thing. Promote it.
Promote. I mean, it's always a delicate balance of showing value to sponsors, which is something I struggle with on a daily basis, because without sponsors, there's no way to do this for free. None. So something like that, if you get to show them an example, totally useful.
Can we just make something really shiny, put their logos on it?
Yes.
Take a nice picture.
Yes. Oh, I finally heard back from Digi today or yesterday. I need to reply to them, but they're like, yeah, send us people's addresses. So
rad.
That was like the entire message. I don't know if it's emails or so. I need to read that, or at least that was what was the title of the message. I haven't gotten into it yet. But yeah, we heard from Digi again, so that's good. And then if there's any, I know we do need better thumbnails on the YouTubes and whatnot, but if there's any ideas you guys have on how to get more people watching the YouTube so we can get our watch hours up or get our subscriber count up, I'd love to know.
I think there's a lot of illegitimate ways to do that. Probably pretty affordable.
Legitimate, sir. Legitimate. I'd rather it be organic and low than fake and high. For a lot of different reasons. One, just for me. I mean, but ethically, legally, I don't want that. I hear you Googling furiously away. I like Elliot. He solves problems. Okay, now, so for those of you that aren't involved in Discord, we had quite an interesting problem with rotary encoders this last week. And Elliot's the one that discovered it.
Created it?
Or created it by buying cheap parts. I don't know. But if you go back to week 1 materials, and we did circuit analysis, and we talked generally about how quadrature encoders work. Well, Elliot was getting different results, right? Like he had to take parts off of his board. He had to go to much smaller capacitors even to get the rotary encoder to trigger. And we were having a heck of a time, trying to figure out what was going on until Elliot took apart a rotary encoder, and that provided the secret. The ones that he got off Amazon, something 11, I forget what the part number was.
EC11, although they don't even have part numbers on Amazon, but they are the most common, like get 10 for $10 all over eBay. They're the cheapest ones. They look like a rotary encoder.
They
work like something else, but they do work.
they do. The software sees them as rotary encoders, but they don't put out a quadrature signal.
They don't.
Not at all. So it's pretty clever engineering, actually. They incorporated the detent spring into the wiper. So
Oh, actually, the detent is on the other side of that little deal.
So what did they do then?
All they've done is they have a single. So let me see if I can. The way it's arranged, maybe I can just share the photo. Let me get on my deal here, and I'll share that screen, so I can at least explain how it's constructed. Okay, so let's hit these buttons. Beep, boop, boop, beep. And that looks good. Okay.
Brian, you have that? Or would you like me to? Okay.
Woo! Classic. Okay. So the arrangement of this thing is, this is the top. This is the top of the rotor portion. Oh, here we go. Let me know when you guys got my screen up there.
I think Brian's changing things. There we
hit the wrong button.
Excellent. Okay, so bottom section of the deal in the center is the push button for the switch. There's wipers on either side, and then this is the rotating portion. So this is the top, and it has like the physical bumps in it. And this little deal here, this is the spring that creates the detents. So this one has 20 detents. And if we flip over to this side, this is the bottom of that rotating portion, my blurry picture here. There are also 20 contacts, and they're all common, so they're all hooked up. And you can kind of see in this image, let's see if we can get even closer. Sort of. This and this are the center pin, the common pin. And then this is just the A, and this is the B. You can ignore those two things. They're not connected. So I think what we're doing here is just connecting at different times, but there's no way to create unless you hold this between detents, both of these, basically this, I think these two are never connected at the same time when it's in one of the detents. So if you have a pull up on this pin and a pull up on this pin, when it's in a detent, it's high on both inputs. As you rotate, I think one gets grounded first, connected first and second. So I think these are offset by a small amount, so that when you rotate it, one makes contact with this contact point here first, the other one second. So you get a transition in one direction, A goes before B, and in the other direction, B goes before A, but they never settle at a high and low when they're in a detent, if that makes sense.
So then the microcontroller then is edge triggered, and it sees that, okay, well, there's an edge, something just changed, but the other one is already in the low state, or it's about to go low.
I think that's what it's doing. Yeah, it's only watching for the transitions, and it keeps track of A before B or B before A, but it's not keeping track of the state of that input.
Yeah. Well, I tell you, Elliot, that consumed a lot of man hours of my life. I know.
I learned something. Learned something new.
Absolutely. I had no idea. Be honest with you, I didn't know that those things existed. So now the next question is, how common is it?
Well, so let's do this. Oh, that's not good enough. So if we look at this, let's just pick one. So this is what, where'd that go? This is what the datasheet says. It doesn't say the word quadrature anywhere. And in this diagram, it has this note: the stable detent position cannot be identified in phase B. And it doesn't really, I guess it doesn't matter if it's pulled down or pulled up, as long as you have the opposite going on your common terminal. But it doesn't really make it clear from here that when it is in a detent, both of these A and B are going to be at the same voltage. I'm not getting that from this picture. I don't know if you guys are. And then I think this is the one we're using, which is real.
The PL12. Yeah.
And here, it's not that different looking, but I believe, since they wrote the word quadrature on the data sheet, that this one is real. But I don't know how common it is to have. So they're both incremental. So yeah, you tell me.
Well, I think if this course has taught you anything, it's to develop a deep-seated hatred for the people that write these data sheets.
Well, it's even, I mean, if you go on Amazon, they don't even give you a part number. I just guessed, right? Because there's a little there's a sticker on the Ziploc bag that it showed up in that said a whole bunch of characters in a foreign language and then EC11. But that's not even a full part number. I mean, which one is it? In fact, I don't even see one here with a threaded like boss on it. Maybe this guy, I don't know. Nope, these are all smooth. So it's almost as if there is no data sheet.
Yeah, that is, well, you know something? Now we know. But we also know that, if we were able to find a data sheet for that, it's going to have different timings, which then necessitates different component selection. And in our case, even a different circuit. We would need a different circuit to make this work, as you discovered the hard way.
Yeah, and I would not have, I guess this is what would have told me it needs a different circuit, but wouldn't have guessed otherwise. Like just series, well, I guess just a pull-up, no capacitors here. Right? And in this circuit, it looks like we've drawn with different values, but otherwise quite similar.
Yeah.
A lot smaller cap too.
Yeah, so this would work. Yeah, because we're using one, right?
Yeah, just because I didn't want to add another line item to our BOM.
Sure.
But yeah, 0.1 microfarad, 0.01 microfarad, they're pretty common engineering things, engineering values. I can't think of the last time, even though it's a good idea, I can't think of the last time I used like a 10 microfarad for a decoupling capacitor, just because I would have probably had a 1 microfarad doing something else. I would have just used that in the circuit, again, in the service of keeping the line items on the BOM low.
Sure. Well, I will say that even though this isn't a real quadrature encoder, they work really well. I've used them like in a lot of different things with a lot of, well, probably 4 or 5 different libraries, like Arduino libraries, and now using this guy, this Circuit Python one, and works great. Didn't have to make any modifications, didn't really have to even read it and understand how it worked. I just typed this in, I created the object, and then you can just read it, just like this. It's magic.
But yeah, you wouldn't, there would have been no reason for you to dismantle one of those parts.
Right, because I'm
when things were
never
working,
using passives when I use these things. That's why.
Yeah. It wasn't until you tried to do things the right way, Elliot, that it bit
Hey.
you in the butt.
I'm trying to. What is that teaching me here?
Nothing good. Not a good lesson. No. Very cool. So
Yeah, we've learned something. That's a good sign.
it is good things. Let's get back to our quad view there. Well, anything else for the good of the cause, gentlemen?
I posted the first and only thing in the forum this week. It's super easy, but if you're putting a footprint in your board that's not part of your schematic, like a mounting hole or even your board outline, add it to your schematic. There's a symbol for mounting holes and you can associate it with a footprint, because this is going to help you not accidentally remove them in the future.
That is excellent advice.
Yeah, because there's something that happens in KiCad especially that there's a checkbox somewhere that when you're updating I think it's when you're updating your board from the schematic,
Yep.
that it will remove unused footprints.
Yep, or even just updating footprints will, I'll wipe them out
I had to
sometimes.
replace my board outline about 10 times before I found out about it.
Thanks, Paul.
So, all right. Well, this week, capture your schematic if you haven't already. Figure out what you want your board to look like, because next week we're going to do the layout. I know it's going to take longer than 5 hours that we generally recommend. I don't know how that's going to work with people and Thanksgiving holiday. If they're traveling, if they have family over, they're not going to have that extra time. So we might be in next week's lesson for 2 weeks. We'll do some polls and see how people are doing and what level of help and assistance they need. I would like to keep rolling because I really would like people to get these things back by Christmas. But that's a somewhat artificial constraint, right? If we need to do it after, we do it after. So how's the pace and everything else for you? I know I'm getting in some of the online, not the online quizzes, the forums, but in some of these surveys that I'm taking, some people are complaining it's too fast. Some are complaining it's too slow. One guy straight up called me a liar. It's like Mark says this is going to take, 3 to 5 hours a week. It's going to take you 3 to 5 hours a day. I'm like, oh, dang, I'm sorry. I didn't mean for that to be the case. I don't want this to consume your life. But
yeah, I've probably spent that kind of time, but I've also 3 or 4 weeks ahead at this point. So
yeah.
And
Elliot, man, is off the charts. This is his full-time job at this point, it seems.
It's my full-time hobby. It's winter now. Well, it's fall, but it feels like winter.
Don't even talk about winter.
But I've really been blown away with what you guys have been coming up with. It's been great. So, Matthew, how's the soldering going?
Well, I've got 1 4/2, 1206 soldered. First time ever. It definitely made me step outside my comfort zone. It's all been true hole to date.
That's where you learn.
Yep.
Did you get any flux?
Yep. Got myself a nice little syringe. Sweet. And it definitely helped. I did the first one without, the next 4, and it went so much easier.
Yeah, so. It really does. It really does. So, well, very cool. And then check back a couple weeks and you can see Brian's stick vise. Something to hold so you're not chasing your board around the table is pretty handy too.
I picked this up.
Oh, nice.
Screw standoffs. You just squeeze the board in between it. You can move them wherever you want. It's all magnetic. My one complaint is this gooseneck on this lamp is not, I can't get it where I want it. but
So-
I think it was maybe 18 or 20 bucks.
There's an innovation that all of these things need that I learned about. They need a turntable that has like a detent at 180
Yeah.
degrees. Because when you find a comfortable position to solder one end of a component, wouldn't it be great just to flip it around exactly and just hit the same thing? My board is round, so everything's at like a 45-degree angle from the last one, and it was really frustrating when you gotta like rotate your whole workbench to get there.
You need a rotary work positioner.
I'll have
Speaking
one,
of,
I'm sure, soon.
yeah, right. Of the 180 degrees, that's some of my very first board holders for soldering, plated through hole parts. They're built that way. So it'll hold the panel and then it'll flip the whole panel over and, you know, flip it back. And it's spring-loaded detent to hold it in position. So once you get it where you want it, I've probably got 3 or 4 of those. They're huge. I never use them anymore. Not the Panavice.
Yeah, well, it can do the same kind of thing. It's got, you know, it swivels pretty nicely.
Yeah.
Yeah, I want it to be like lazy Susan with like a little detent, so you can just like whip it around the other way, have your little holding devices and everything follow it or not. Like, it needs to be awesome.
So you're saying take this and mount it on a Lazy Susan and
Exactly.
put some stops
And
on it.
put a magnet on it and some magnet on your desk. Then that would be really great.
That's going to be the improvement I'm going to make on this. Is embed magnets in the bottom, so that when I have my work surface have some steel underneath it somewhere, so I can set it down and it won't move. But I
did that.
I can turn a little bit and it'll turn.
I did that with a breadboard because I had a piece of metal on my bench. All that happens is the magnets fill up with the little legs of components and like pieces of metal that from drilling things and other like bits and pieces, grinding dust, and they end up being horrible.
Like the magnetic closure on my tablet case that I used in machining classes, where
so all the computers
in there.
All the computers in my shop and my cell phone, like the microphones on them, they grow fur, and they look like that funky like mustache eyebrow toy with the iron filings in it. Yeah,
pretty much.
I think it's called Harry Gary or something like that.
Yeah, exactly.
My boss's name is Gary.
I just make everything really heavy now, and it seems to do the trick.
Well, at some point, not anytime soon, I will clear off my workbench and show you the madness that I have. I use an optical breadboard. I've got a 1/4-20, 1 inch on center, and I made a bunch of 3D printed jigs to hold things, and man, they don't move. So anyhow, gentlemen, thank you so much for joining me. I appreciate your time, and I appreciate the support of our sponsors, Royal Circuit Solutions, Advanced Assembly, DigiKey, Walkwee with Yuri. Yuri, you're great. We love you, dude. We've also got theanalog.io, a great little newsletter. If you haven't seen it, you might want to check it out. Sign up. It comes out every Wednesday, I want to say. And other than that, we'll see you all. You guys want to do this again Monday?
Sure. I'm not a town, so I probably won't. But yeah,
I may drop in.
Okay. So we'll probably see you this time Monday when you're doing board layout. I will have some videos up for you this week. I don't know how I'm going to edit them. I don't expect anybody.
Just accelerate it till it's 30 minutes long, and then pause and narrate. Do a voiceover. Be like, look here. I clicked on
really
that.
excited. I'm not on meth. You know, it'll be fun.
Yeah.
All right, everyone. We'll see you at 6 o'clock Pacific on Monday, and have a great week and a great weekend, gentlemen. Thanks again.
See you guys.
Thank you.